Okay, I will talk about the theory part of the electromagnet. So, what does the electromagnet related to our theory? Which is the theory we will related which is the Ampere circuited law. So, what does the Ampere circuited state? Is that the line integral of the H, which is the magnetic field intensity around a closed path, is the same as the enclosed current by the path. So, below is the formula of the Ampere circuited law, and okay, using the formula of the Ampere circuited law and you also using the formula of this one, which is B equals to mu naught H, and B is the magnetic flux intensity. And by manipulating the formula, we'll get the formula as below, which is the B dot dl is equals to mu naught I enclosed. And this formula states that the line integral of the magnetic field around a closed loop is proportional to the current passing through the loop. And here is the simplest explanation of the Ampere's law. And a wire that carrying current will create a magnetic field around it. The Ampere's law tells us to create an Amperian loop. The magnetic field at every point of the loop will equals to the permeability times with the current. So for our electromagnetic experiment, we'll use many number of turns of the coils to enhance the strength of the magnetic field.
So, Assalamualaikum, hello everyone. So this is the video for our group. Right now we are trying to demonstrate on how electromagnetic induction works. So we have right now a battery which will supply the current and voltage to our wire. So this one is going to be a copper wire, it's an insulated one. But if you want it to be exposed, can also. And then you will have like a long big nail, which is going to act as an iron core. So this iron core will somehow the current will develop an electromagnetic field, and the electromagnetic field will be concentrated on this nail, which acts as an iron core. So what happens is that after right now we are not connected to any current source, so no current flow. There should be no electromagnetic induced. So it's not going to attract any form of metal or conductor. So after we apply the current to it, so it's going to be quite a little hot for my hand because there's no resistance. So yeah, right now it's currently connected with the battery. So it's quite hot, but I cannot feel it. I can feel it. So right now there's current, so it should somehow induce an electromagnetic field. So let's try it. So yeah, because this is quite heavy, but actually you could see that there's something going on. Takut pula. Asal takut pula ni? My bad. Tak ada terbalik. Sama je. So maybe I didn't fully. Okay. Yeah. So it's going to be attract. So after there's current flow, it will induce an electromagnetic field and attract as a magnet. Yeah, but it could be clearly demonstrated if you use a lighter object. So this one is quite heavy, but still it can attract it. So if I were to apply more turns on this number of turns here, so the solenoid, it will be stronger. Yeah, it will be stronger. So let's say that I compress this and maybe just a little bit more turns here, over here. Yeah, by doing this, theoretically it should produce a more stronger magnet. But maybe because there's just a few turns, but if I were double the turns, then it would be more clear the effects of the above coil. Right, so that's it for our simple experiment. So a few things to note is that what makes the electromagnetic field stronger is the current that flows through it. The stronger your battery, if I were to use a 9-volt battery, it would be very strong, but then again it would burn the wire actually because we have no resistor right now. And if I were to use this different material, because different metal has different different capabilities for concentrating the magnetic field. So normally people will use laminated iron core, and yeah, the wire also plays an important role, and also the number of coil. So the higher number of coil, the stronger it gets, the higher the current, the stronger it gets, and yeah, the different material also plays a part in the stronger the electromagnetic field is. So that is for our simple experiment. I hope this helps you all. Thank you.
The next part I will talk about the application of our experiment in industrial practice. As you can see in this image, this device uses a large and powerful electromagnets. Its device is usually to lift, move, and release ferromagnetic material like iron and steel. One of its key advantage, which is the ability to separate between ferromagnetic material and non-ferromagnetic material. This is quite useful because the process of sorting and handling material will be much more efficient. Okay, next I will talk about the how it works. First, conductive wire is wrapped around the iron core. The wire is usually using copper because of the high conductivity. When electric current is passed through this wire core, it will generate an magnetic field around the iron core. This magnetic field is strong enough to attract and hold ferromagnetic material. And when the current is switched off, the magnetic field will disappear and the material will release.
Another interesting application of the electromagnet is the maglev train. And what is maglev train? Is the transport system that is widely used in the modern country like China and Japan. And it is using the electromagnet to create the electromagnetic force to alleviate, propel, and guide the train along the track. And this also show that there's no any contact between the train and the track. This also show that there's no friction between the rails and the train, which allow the train will be moved with very high speed. So how does maglev train works? So as there's the presence of the electromagnet at the bottom of the train, while the rail will act as the ferromagnetic materials. So we'll divide the process into three parts, which is levitation, propulsion, and guidance. So for levitation, as you will lift the train above. So as the train move, the induced current will produce at the rails, which will generate the opposing magnetic fields, and they will push the train upwards. And the track contains coils that can produce a traveling magnetic wave, and the wave will interact with the electromagnet on the train, and this will producing the force that can push the train forward or backward if needed based on the current direction. Now this is called the propulsion, which is guiding, letting the train to move forward. And in order to maintain the stability of the train, we'll add more additional electromagnet at the side of the train. So so this will allow the train not to wiggling because the train is moving at very high speed. If the train is wiggling, they will be very struggle.